So now we want to prepare our patterns for casting. But in order to cast it, we have to invest it. The inlay will be transformed, our wax pattern will be transformed in an inlay made of noble metal. So you see the sprue, it's a pin-like, a cylinder-like plastic or wax. And then you see, so this is the sprue, right? The sprue is this pin. And then on this sprue, you see a reservoir for melted metal. In between this ball-like reservoir and the very pattern we created before, there is like 2 millimeters, which is the isthmus. That's what we call the isthmus. So a little bit of the sprue in between the metal, the reservoir, what will be the reservoir for the cast metal, there you see now, and the pattern, the wax pattern itself. So everything, as you can see, is connected to our inlay pattern. The technician waits for the cooling of the wax. And now, once the wax has cooled down, we slowly, carefully remove the whole thing from the model, from the die actually. And we apply some alcohol because we don't want grease on the surface. All residues of grease from our finger, from the atmosphere, they will prevent the investment material to cool, to flow nicely and evenly and smoothly on the surface of our pattern, what we don't like. So now we want to know the weight of the wax, and we will multiply the weight of the wax with the density of the metal to know how much metal we have to use, and we shall still add something more just for sure, just to make sure that we're not short of metal in our melting and casting process. Well, now we have this wax pattern with the reservoir, with the sprue, as I said. So this together is fixed on a cone. You see the cone? The cone that belongs to what we call a conformer, something that conforms the shape, the exterior shape of the cylinder in which we will place the investment material. Investment material, which is nothing but a plaster that can withstand very high temperatures, 1000, 1300, 1400, 1500 degrees even. The inclination of this sprue is like 45 degrees around. You see, the reservoir will be in what will be the center, the thermal center of the cylinder. But of course you have to know your cylinder, so the technician knows what he's doing here. She was a very, very good and famous dental technician. It's a privilege to see her demonstrations, but sometimes you see you have troubles even if you're highly experienced with wax. Yes, this is a spatula that was placed in fire. With electric spatulas, it's less likely to have these problems because the temperature is always controlled. Yeah, but dental technicians who like fireworm spatulas, they like this because they can blow a little bit of air and then they modify the temperature very quickly. Yeah, you need experience to do this. Anyhow, so you see this whole thing together, sprue, reservoir, and pattern, is connected to this cone. With wax, the connection has to be very well done, and it doesn't have to be very thick, but it has to be done very well without any holes or scratches or something. You want to create a very smooth surface of the wax, because then in the investment material this will become a system of holes. Actually, when the wax will melt, we'll see this, how it's done, and then you want all those inner structures, holes and canals, to be very, very smooth. So you have a smooth wax, you'll have smooth canals afterwards. Just remember this and you will see exactly how it goes. It's not very easy to imagine because you pass from a positive to a negative and then back to a positive, but we'll see it. So now the technician is doing the same for other patterns. For example, in this case, this is a mixed metal ceramic crown that we want to produce here. The method was invented by the Heraeus company. It's a German company from Hanau near Frankfurt. They have the headquarters. Now I think they belong to Mitsumi Group from Japan. Anyhow, so but this was like 50 years ago, right? 40, 50 years ago, that they came up with this idea how to cast the metal. There are many other techniques, but this is the one we present here of casting metal. So again, the sprue, right? And now you see there's no ball there. That's an interesting thing. Shall the technician place a ball, a reservoir, or not? We shall see, because you see the metal there is very thin. Unlike the inlay, which was full metal, here we just have a coping, and over this coping we'll place ceramic, yeah, to make a metal ceramic crown. So maybe the technician choose to place a thicker sprue and no ball for a reservoir. Sometimes they do it like this. Other times, or other technicians, they always place a reservoir, especially because here the metal is likely to be non-precious metal, right? So non-precious metals, you don't care if you use a little bit more. What, like 1 gram maximum, half a gram, 1 gram. That will remain in that reservoir. Now you see the die is taken out from the model because we need to remove the hole very, very carefully. And that's what's done here. Slowly, slowly, nicely. Of course, all these patterns have been removed previously. You don't remove them now together with the sprue. You did remove them before, you place the sprue, and then you carefully remove them to put them on the cone. Degreasing, as we said before. So this is done, and now we'll do the same for the pattern of the bridge. That's metal ceramic bridge here. And so again, this is the sprue. Actually, from this sprue, we will remove, you see, we will remove most of it and leave the isthmus there. The isthmus is left on the pattern itself, the 2 millimeter isthmus. So there's one isthmus, the second, there's one isthmus for each element, as we say, be it coping on the die, or be it pontic, that is in the edentulous area. One thing is one element, right? That's what we call it in the lab, element. So third element, and now the fourth element that receives its isthmus, part of the sprue system. That's the Heraeus technique. This has to be, again, as we said, this has to be very carefully connected, and we don't want to have any holes there or anything left over, so to say, or anything that has not been properly connected. plus or minus, nothing. It has to be as clean as possible. And now we start with the main reservoir, which here obviously is not one reservoir ball-like for each of these elements, but one cylinder-like reservoir for all of them. We're gonna see in a minute. So the wax was warmed up there on the tips of the isthmuses, and now the technician will bring the main reservoir. Again, it's part of a sprue, a thicker sprue. I mean, this was prefabricated. You don't have to roll it down to make it to look like this. You just buy it like that. And now, once it has cooled down a little bit, you see the technician still keeps the finger there to make sure. Now you just stick it to the rest of the structure. And that will be the reservoir for melted metal. Now you will ask yourself why we need reservoir. Because the pattern will cool down first when you cast the metal. And when it cools down, it shrinks. And to compensate for this shrinkage, it has to take liquid metal from somewhere. And this somewhere is the reservoir. Well, we'll see this in detail when we speak about how it's casted. But now it's just to have an idea and to understand a little bit why we do this. So it doesn't have to be longer or bigger. Of course, if it is longer, there's no tragedy. Nothing happens if it's longer, but you don't need it. And it just takes space in the... On the other hand, it can get too close to the margins of the cylinder and cool down faster, and we don't want this to happen. We want this reservoir to cool down the last, okay, to keep liquid metal for as long as possible. So now the main sprues are connected to the reservoir, to the cylindric reservoir. You see those are two sprues. This is the classical way of doing it. Many technicians now don't do it like this anymore. There are more modern techniques, but this is the classic one. And yeah, we're not technicians, so it's just for us to understand the process. Yeah, it doesn't matter. You do it one way or the other. This is grandpa style, right? And again, you have to make it smooth and nice, because where you see wax, in the investment material we shall have canals, right? Smooth wax, smooth canal walls. That's the idea. And nice flow of the metal without hindrance. And the metal flows nicely, the metal fills everything, the job will be done perfectly, right? Again, degreasing, this is important, as we mentioned before. You see 4 elements, 2 are pontics and 2 are copings, simple copings, as we say, and we place it on the cone. Now, of course, if you... Sorry. We should weigh. Yeah, right. We should know how much we need to know how much metal we have to use. So now we put all this together. This will be transformed in metal, in non-precious metal. The inlay was placed separately because that was to be precious or noble metal, right? But the non-precious metal that we'll place ceramic upon, we cast together the two things. Yeah, the simple coping on the central incisor and this bridge. Not to be understood that noble or precious metals don't go with ceramic. They do. There are some special alloys, noble alloys, precious alloys, that are specially designed for ceramics. Yeah, but non-precious metals for inlay, this is not normally used, right? So inlays are almost always, when they are metal, they are precious metal. While metal ceramic, it can be precious metal or non-precious metal, and ceramic placed upon. So again, we fix this to the cone, as we did with the inlay in the previous images. So now the second element that we want to cast together with the bridge, yeah, in one casting. So this is the coping for the central incisor, for the metal substructure, yeah, the metal coping that will be then covered with ceramic. You see a little pin on the lingual of this coping, a bluish-like pin. This is designed specifically for the technician to use it as a holder when it places the ceramic, right? Because it will be all covered in ceramic, so you need this small pin like a holder.